I'm going to do something a little bit different. I have a Posit cloud environment that I will link in the chat. And you can follow along if you'd like. It might prompt you to log in with either a GitHub account or a Google account or with a Posit account, but otherwise you have complete access to this. So this is a sort of a sandbox environment to play around with the package. So first, what I'd like to go through is define what is a treatment pathway. So let's say we have person 1, and the person has a disease for some period of time, and over the course of the time receives some treatments. So first, this person receives treatment A, then treatment B, and then at the end of treatment B also receives treatment C. So if you collapse that down into one pathway, you might say that this person first receives treatment A, then treatment B, and then a combination of B and C. And treatment patterns does this for all your patients that are defined within your target cohort and your event cohorts. So the treatments are, we call those event cohorts, and then your group that you want to build treatments in or pathways in is a target cohort. I've also linked some publications, as this is not a new idea. I believe George and Patrick have published something in 2016 already. And furthermore, I'd like to shout out Anik Marcus, who initially built this package based on the OMO CDM. For further reading or documentation, there's also links for specific documentation, so function references, and also like vignettes to sort of demo the package. So first, I will just load in my dependencies that I need. Then I will, you've seen Marty and Gib create cohorts using a CDM reference. I will be using connection details using database connector and cohort generator. So this should all feel pretty familiar. So this is just code copied from cohort generator. So we can generate our cohorts. So I'm just going to do that real quick. So this will probably take a second. So treatment patterns supports both the CDM reference from CDM connector and database connector. So the cohorts are generated now. We can then see what is generated. So here you can see several thousands of entries for several cohorts. Then we need to specify what cohort is what kind of cohort. So like I said earlier, we have a target cohort and an event cohort. So here we see with viral sinusitis, which we consider a target cohort, and within viral sinusitis, we're building pathways using these drugs, these event drugs. There's also an exit cohort in there that is out of scope for this tutorial. If you want to know more about that, I point you towards the documentation that I've linked at the head of this file. We can then build our treatment pathways. So the first couple of arguments is just pointing at where our cohort exists, in what schema, and where it should write results to, and such, and our data frame of what cohort is an event cohort and a target cohort. Furthermore, we have several more options to specify how our pathway should be built. So think of what is the minimum duration of each treatment that should be picked up, how much should two cohorts overlap or two treatments overlap to be considered a combination treatment. So we can execute that. It will spin up some messages of what it will do or what it's doing and what it finds. So the output of this is a Andromeda object with all intermediate data. So this is nice if you want to use treatment patterns, but then do your own customized analysis based on it. So here we have a treatment history table. So this is for each individual person and each individual event, a record. So we can then say, we filter this and look at a specific individual. Here we see 3 records. So this person first receives aspirin, then acetaminophen, and then a combination therapy of amoxicillin and clavulanitate. Obviously, this is patient level data, so this is, you can't share this. Obviously, this is in anomia, so it's fine. But what we can then do is export this Andromeda object with a min cell count and age window, and what should we do if a certain pathway falls under the min cell count. So for now, I'm just going to remove it. So we can export it. It writes some files in an output folder. The most important thing is this treatment pathways file, which shows all the treatment pathways grouped by a certain strata. It also outputs some counts and some metadata. You can dive into that further if you like. Here I will filter out men and women for the pathways, and I will set some colors. So this is not very important, mostly for the output to look neat. And we can create a sunburst plot that you might have seen and a Sankey diagram. And then I will display this in this viewer of RStudio. So here we see two sunburst plots, so one for male and one for female. And what we see if we hover over this interactive is that the most common first-line treatment for males is acetaminophen, and the second most aspirin. And then for women, for instance, we see that it's the same. And you can trace down all these pathways and get certain percentages out of these figures. Furthermore, you can also make a Sankey diagram. So this might be a little bit more familiar to a lot of people. And it's basically visualizing the same data in a little bit of a different way. And that's it.